This video serves a simple purpose. I want to demystify the most advanced TypeScript and show you that it can come quite naturally. So next time you see this type or that type, I promise you won't get overwhelmed. The only prerequisite being comfortable with JavaScript and ideally knowing TypeScript generics, which you can learn quickly from my other video. The central topic we will cover is a JavaScript function pick. It takes two parameters, an object and a string path to a property anywhere deep within it. So if I say pick object A, I'm gonna get 1, and if I say pick object dfg, I'm gonna get 30. Do you know how to implement it? Here's an example. Split the path by the dot into an array of segments, start with the object passed, and for each segment keep digging into the object so that we go from object A to object AB to object ABC. Finally, return the value. And this is JavaScript code doing all that. But here's the TypeScript question. How can we type the path? It cannot be just any string. As you can see, it should support and even autocomplete only the paths that are valid for the given object. If I pass an unrecognizable path, I'd expect TypeScript to complain about it before I get runtime error. We accept only string literals that represent the possible paths in the object, such as ABCD, and then DE/DF, and then DFG. The proper type given this object would be as follows. It's a set of values represented with a union type. Any other type isn't as precise. Now, we just defined our TypeScript problem. Given an object type, find the type of all the possible paths within it. How do we go about it? Let's say our TypeScript isn't perfect just yet, and change the question a little bit. Given an object in JavaScript, can you return an array of all the possible paths to its properties? So, given this object, we want our function findPaths to return such an array. Notice that we support string and number keys, but nothing else, so we can ignore symbols or other objects. Here's a simple implementation of findPaths. We go through every object key. If we meet an object, we recursively call findPaths to keep digging. If not, we reach the end of the path, and now we can add the key to the result. So we get A, B, C, D, then at D we meet an object, we get E and F from it, at F we get an object, and there we get the final key, G. Concatenate keys with a dot, and there's the expected function result with all the possible paths. Let's summarize the specific JavaScript features we just used. Object keys to get keys as strings, flat map to get many paths from a single key, a ternary operator, a condition to check if the value at a key is an object, string concatenation, and recursion. Why all the fuss about the function getPaths? Because the JavaScript function and our TypeScript type path are the same computational problem. Finding a set of all the possible values a valid path can take. In JavaScript, the result is a JavaScript array of JavaScript strings. In TypeScript, the result is a TypeScript type, which is a set of all possible string literals. This analogy would have been even more precise with a JavaScript set instead of an array, but I intentionally chose an array for simplicity, and the paths we generate will always be unique anyway. Now, let's talk JavaScript features versus TypeScript equivalents. In TypeScript, to get the object keys, we use the keyOf operator. That works, but alone doesn't help us address each individual key and decide what to do with it. To get our flatmap equivalent, we use map types. Just like in flatmap, you can map a single value, object key, into a set of many values, a union type. The ternary operator in TypeScript is known as a conditional type and has exactly the same syntax, except its condition must be based on extends. With extends, you can check if a type is assignable to another type, so for instance, check if our value type is an object, like we did in JavaScript. String concatenation. Template literal strings give you exactly that with types. In JavaScript, if we have an array of strings, we have to map them. But in TypeScript, a single type can represent many values, yet we use the same syntax, and TypeScript will distribute all the possibilities for us. Recursion. Just like we call the JavaScript function by its name in the function body, we call the TypeScript type by its name in its type definition. Lastly, merging results. In JavaScript, it's array concatenation. In TypeScript, a union type merges two sets into one. These are all the features we compared between the two languages. I hope you can appreciate how similar the syntax is between most of them. Okay, now the finale. I'll prove to you that I can directly convert our JavaScript function getPaths, returning an array of JavaScript values, into a TypeScript type path, computing a union of types. First, let's get the object keys with the keyOf operator. It works, but it isn't of much use if we cannot target an individual key like in flatmap. So let's use a map type. If I leave it like this, I get just the object type. But the trick is to get its value type, so I need to access the object by the very keys we just saw. Voila! Unfortunately, keyof doesn't filter out keys such as symbols as we had it in JavaScript's object keys. We need to do it manually. We can use a conditional type to check if the key is a string or a number. If not, we return never. Think about it as an empty set. Okay, we already got something. Time to tackle the deeply hidden keys. Just like in JavaScript, if we meet an object at the key, we go deeper. If not, the key itself is the result. As you can see, the check works. Our nested object at D is detected properly. Finally, let's use recursion to handle the case with an object. Just like in JavaScript, we combine the current key and all the recursive paths from it with a template literal. And that's it! Our TypeScript code, mimicking our JavaScript code, finds all the possible paths given an object type. Once again, I hope you can really appreciate how similar both of the solutions are. Okay, so we tackled our main quest, the path type, but we completely ignored the return type of the function pick. Because if I specify the key A, I would expect TypeScript to know that the return value is of type 1. And if I specify the key dfg, I would expect TypeScript to know it's precisely 30. I'm going to leave this as a challenge for you and share a couple of tips on how to accomplish it exactly as we did for the path. First, you have to realize that this problem is the same as what the function pick does. Given an object and a path, find the value at the path. However, our function uses a for loop instead of recursion, so to convert it to TypeScript, you'd need to rewrite it. Next tip, we need to capture the specific path passed to the function, so it must become a generic type parameter of the function. And lastly, to break down a string into two strings in TypeScript, use the following syntax with Infer. If you want to inspire yourself, a partial solution was shown at the beginning of the video. I want to conclude this video with the following. We touched upon the most hardcore TypeScript features: generics, indexed access types, map types, conditional types, recursive types, and the infer keyword. Obviously, I highly encourage you to learn all of them, but most importantly, with just one example, we showcased why we want all these features and that any TypeScript problem is just a programming problem. So if you know JavaScript, even that can be a great bridge to advanced TypeScript. And I hope next time you work with complex types, you're not going to fear them anymore. As always, thank you very much for watching and I wish you the best of luck. To learn TypeScript or JavaScript, subscribe and watch my other videos.